So in the previous videos that I've uploaded on this channel about FPV drones, explaining the whole concept and explaining the half-built model of my RC airplane, I think I missed out a very important concept called motor rating and DC brushless motors. So DC brushless motors in battery-powered RC aircrafts and FPV drones are the main source of propulsion for the aircraft or for the drone to fly. And so understanding the motor rating, what kind of motor has to be used, what size motor and what speed motor must be used is very important to prevent any damage or any instability caused to the aircraft when it's flying in the air. So for this video, I'm going to use the simple example of a 1000 kV motor. So kV, when it comes to motors, stands for constant velocity, which means for every 1 volt of electricity supplied to the motor when it's connected in a circuit, it's going to rotate at a certain rotations per minute. So this 1000 kV motor means that for every 1 volt of electricity being supplied to the motor when it's in a circuit, it's going to rotate 1000 rotations per minute. So if I'm going to connect this to an RC aircraft, which is using a battery that can supply about 10 volts when it's flying at maximum speed, then 10 volts multiplied by 1000 would give you a maximum RPM of 10,000 RPM, which can generate immense amount of thrust, and that's more than enough to propel the aircraft forward. Now again, it depends on the size of the aircraft, the weight of the aircraft, and the material that's used to make the aircraft to decide finally which motor that you would need to use. So for the aircraft that I've been building, which I made a video previously on, which is still not completed yet, this 1000 kV motor is the ideal one, and using a 10-inch propeller, it can generate enough amount of thrust to propel the aircraft forward. Now what actually happens when you use an overpowered engine or an overpowered motor? So when you use an overpowered motor, you're basically going faster and faster and faster. When an aircraft is going in the air, when it flies stable, to us, when we're on the ground or when we're in a real aircraft, it might seem like the aircraft is stable and not experiencing many resistive forces on it. But when an aircraft is actually stable, the only stable factors here is the force of lift, thrust, and drag. But there are a bunch of other resistive forces that the aircraft experiences, and if the airframe is not strong enough to handle those forces, the airframe can just fall apart. So in the case of RC airplanes, if you're flying faster than what the airframe can handle, the airframe can essentially snap out, which means the wings can get separated from the fuselage and the aircraft is going to crash. And that's why it's very important to use the right motor and fly the aircrafts at the right speed, at the right throttle level, so that you avoid any breakage of the fuselage while it's in the air. So a lot of higher powered motors like 2200 kV motors and 2300 kV motors are not really used for RC aircrafts because those tend to be very, very powerful, and no RC aircrafts actually need them to fly stable in the air. Therefore, those motors are usually used with smaller diameter props like 5-inch or 7-inch props on FPV drones, which use about 4 propellers and 4 motors to generate enough thrust and fly in the air, because these are drones that are supposed to fly at high speeds and be extremely maneuverable, and therefore they require that kind of power from every motor. So that was basically it, what kV means and what motor rating is, and the kind of motors that are used in RC planes and drones. If you like this video and if you're interested in more topics, like this video and subscribe to the channel. I'll come out with more like this very soon. Thanks for watching and see you guys in the next one.